Hi everyone, I want to talk about power in this video. It's pretty simple fact. It's either defined as change in energy per unit time, like in this equation here, or work per unit time, and we know work is equal to change in energy. We can derive an equation also to show that power is also equal to force times the velocity. Simply work per unit time, and work can be replaced by force times the change in distance delta x, and we knew from past that delta x over delta t is equal to velocity, so the power can be defined as force times the velocity. Unit of power will be what? And it's pretty simple to deal with power. Over here in this question we're asked to compare the powers of these people who goes upstairs in different times, and what we will do is they will do a work, and that work done is equal to change in energy, which is a change in potential energy. In this case they climb up to a height, so over here they will have a potential energy, down here they don't have any. And we're gonna say power is equal to that work done divided by the time it takes to find who is the most powerful. And again we're gonna replace the work by change in potential energy, which will be equal to mgh, and divide those by times given for each person to find who is more powerful. Go ahead and do that. You'll find B is the option here, the correct option here. This one is similar. We have cars, they speed up to a speed in a certain time. This time's work done, still change in energy, but change in energy here will be only kinetic energy, so we'll have delta ke. So you'll calculate all those delta ke's and you'll say work done for each case will be equal to 1 over 2 mv squared. Kinetic energies goes from 0 to a value of v, and then power is equal to that work done divided by the time it takes to do that work, and the work done you'll replace by kinetic energy, 1 over 2 mv squared, and divided by the time it takes to compare which car has the greatest power, which is what the question is asking, and you'll find it should be the first one. This question is also a similar one. A 100 kilogram weightlifter, that's the weight of the person, performs a lift called a clean and jerk, raising a 190 kilogram bar from the ground to a height of 1.9. I'm going to draw an ugly picture here to show that. So the guy is raising a weight to a height that is 1.9 meters. So I'm going to call this h, 1.9 meters. And the mass of the weight he calls is 190 kilogram. And it takes him 1.8 seconds to do this lift, so delta t is equal to 1.8 seconds. What is his power? The guy will be doing a work, right? That work divided by the time it takes for him to do that work is equal to the power he has, and his work is equal to change in potential energy. In this case, divide that by the time, we'll have the power. Potential energy while the weight is in the ground is 0, so when it gets up there, change in potential energy simply will be equal to U final minus U initial, right? This guy is 0, so simply U final, that's mgh. So we'll insert that in here. Power will be mgh divided by delta t, and that's it. We'll put the mass of the object he lifts, not mass of the person. keep that in mind. Sometimes we have values given to us that we don't need. G is 9.8 meters per second squared, and H is 1.9 meters. All that divided by 1.8 seconds. After we do these calculations, I believe I have the value here. I'll just put it in. System, its power, the power of the person will be 1965.44. So 1965.44 watt unit of power. You can actually calculate each other's power using a similar idea. You can estimate the height of stairs. You can have each other run up the stairs and keep time while one of you is keeping time, and then you say the time it takes you run and the work you do, which will be mgh divided by the time, can give you your powers. Try it.